So today I've been given 4 radical equations to solve, 4 equations involving radicals. I've got the square root of 3x plus 4 plus 1 equals 0. The square root of 2x minus 5 equals 5. The square root of 6x plus 7 equals x plus 2. And the square root of 2x plus 1 minus the square root of x equals 1. So I've been asked to solve these equations, and I want to walk you through how to do each one of these, and as a couple of steps process here. And the first step I always like to do is I like to get the radical by itself. Whenever you're trying to find something, whenever you're trying to solve for something, you want to isolate that term, and that term happens to be x. I want to solve for x. But x is under the radical, so I want to isolate the radical before I isolate x. So to do that, I'm going to move this 1 to the other side. So I'm going to get the square root of 3x plus 4 equals negative 1. Now, at this moment, my brain, a little alarm goes off, and I said, you know, the square root, I like to think of something as simple as 4. The square root of positive 4 is positive 2. Okay? The square root of negative 4 is 2i. It's an imaginary number. Is the square root of a number ever going to be a negative number? The answer to that is no. And so given that particular property, given that particular idea, at this point I can say there is no solution. Well, I always like to play the what if game. What if you didn't know any better and you continued to solve this? Well, if you continue to solve this, you have to get rid of the radical. How do you get rid of the radical? You would square both sides. Okay? So you would get 3x plus 4 equals 1. And you'd move the 4 over, so you'd get 3x equals negative 3. X equals negative 1. And you'd say, okay, well, there's my solution. There's my solution. However, if we check our work, which we always should in an algebra class, that's the nice thing about algebra, you can check your work. Take my original problem, and everywhere you have x, you want to put negative 1. So square root of 3 times negative 1 plus 4 plus 1 equals 0. Well, 3 times negative 1 is negative 3. Negative 3 plus 4 is 1, so I get square root of 1 plus 1 equals 0. Well, the square root of 1 is 1, so 1 plus 1 equals 0. The last time I checked, that is a false statement. And if that's a false statement, what does it say about the answer that I got? The answer must be incorrect. So that takes me back to the solution that I gave you originally, which is there is no solution for this equation because the only solution you could find doesn't actually exist. Okay? So let's move on to the second problem. And the second problem is very, very similar to the first, only this time the radical is already isolated for me. So I'm going to square both sides. And I'm squaring both sides because a square root and a square are opposites of each other. In other words, if I said to you just as a kind of a side note, 5 squared square root, what happens? The answer would be 5 because these are mathematical inverses. Okay? So we're kind of using that property there. We're saying these are mathematical inverses. We're left with 2x minus 5 equals 25, which gives us 2x equals 30, which gives us x equals 15. Okay, so x equals 15, and I'm happy with that, and I'm fine with that. And what should we do? We should check our answer. Okay, so if we check our answer, we're going to very simply just come over here to the side and square root of 2x, right? Because x is 15 minus 5 equals 5. Well, 2 times 15 is 30. And 30 minus 5 is 25. So I get square root of 25 equals 5. 5 equals 5, which is a true statement, which means this is a correct solution. Okay. So our next one, we've got square root of 6x plus 7 equals x plus 2. Again, first step would be to isolate the radical. Well, the radical's already isolated. So what do? I square both sides. So square this side and square this side. Now, before I go any further, I just want to point out something that I see very, very, very commonly. X plus 2 squared does not equal x squared plus 4. That is an absolute no-no in a math course. Instead, x plus 2 squared equals x plus 2 times x plus 2. And you absolutely have to remember that. That is very, very, very crucial. And so if we do that multiplication, x plus 2 times x plus 2, here's what I get. Now here the square and the square root, they're mathematical inverses. They'll go away. I get 6x plus 7 equals x squared plus 4x plus 4. Now previously, what did I get? I got a linear equation. Get x by itself and you're done. Here I did not get a linear equation. I got a quadratic equation. X is to the second power. To solve a quadratic, you have to set it equal to 0. So when I set this equal to 0, subtract 6x from both sides. So 4x minus 6x is negative 2x. Subtract 7 from both sides. 4 minus 7 is negative 3. This is what I get. And then I can factor this, or I can use a couple of other methods. But in this case, this factors very nicely. It factors into x minus 3 and x plus 1. And when we factor a polynomial, the easiest way to solve it is to set each factor equal to 0. And if I do that, I get x equals 3 and x equals negative 1. Okay, so there's my solutions, and I'm happy with that. The last thing I need to do before I continue is to check my solutions. So the way I'm going to do that is take my original equation, and I use a different color to check my solutions. So I say the square root of 6 times x plus 7 equals x plus 2. And I'm going to do that for both of my solutions. So 6x plus 7 equals x plus 2. Now, my solutions were 3 and negative 1, so I'll put a 3 there and a 3 there, and I'll put a negative 1 there, and I'll put a negative 1 there. Okay, and I'll whittle through these. Well, 6 times 3 is 18, and 18 plus 7 is 25, so I get the square root of 25 equals 3 plus 2, which is 5, which is 5 equals 5, which is a true statement. Okay, here 6 times negative 1 is negative 6. Negative 6 plus 7 is 1. And negative 1 plus 2 is 1. And the square root of 1 is 1. So I get 1 equals 1, which is also a, lucky for me, true statement. So what do I know about these two solutions? They are both correct. Okay? So that's how we work that problem. Now, the last one is by far the most difficult of these problems. And you have to go back to what I said originally. The very first step with a radical is to isolate the radical. Well, in this case, I have two radicals. Pick one. I'm going to pick the difficult one, 2x plus 1, and isolate it. Now, what does that mean I do with the other radical? Move it. So, if I move that radical over, I get the square root of 2x plus 1 equals 1 plus square root of x. Now, step 2, once you've isolated the radical, is to square both sides. For the left-hand side, that's very easy. I get 2x plus 1 equals. For the right-hand side, you've got to remember, this is equivalent to 1 plus square root of x times 1 plus the square root of x. And if I do that multiplication, I'm going to end up with 1 plus 2 root x plus x. Okay, and that's just using the FOIL method. 1 times 1 is 1. 1 plus root x and 1 plus root x add up to give me the middle term. Square root of x times square root of x is square root of x squared, which is just x. Okay? So I get this. Now, again, up here, what did I do? I noticed I had a quadratic, and I said, oh, I've got to set that equal to 0 to solve it. Down here, what do I notice? I have a radical. How do you solve for a radical? You isolate the radical and then square it. Okay, so I need to isolate this radical. Now, what does that mean for me? Well, I'm going to move this 1 over. I'm going to move this x over. So 1 minus 1 gives me 0. And 2x minus x gives me 1x. Last step, I still don't have this isolated. I'm going to divide both sides by 2. So I get x over 2 equals square root of x. Now what? Square both sides. This will cancel. And this will give me a very interesting thing here. So x over 2 squared is x squared over 4. And that equals just x. Now I like to cheat. I don't want this in the bottom, so I'm going to multiply both sides by 4. If I multiply both sides by 4, what do I get? I get x squared equals 4x. What do I have? I have a quadratic. How do I solve a quadratic? I set it equal to 0, which gives me x squared minus 4x equals 0. And then I factor this. Well, that factors into x times x minus 4. And this gives me x equals 0. And this gives me x equals 4. And so I'm very happy because there are my solutions. Except one thing I have to do. I have to check my answers. So I say, okay, well, let's check my answers. And sometimes I do these in my head. Sometimes I write them out. For this particular problem, I'm going to go back to the original problem. I'm going to do them in my head. So I have x equals 0. All right? Well, 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. So this whole quantity will give me 1. Square root of 0 is 0. So 1 minus 0 equals 1. Is that a true statement? Yes, it is. So this is a correct answer. How about 4? Well, I go back up here, and I'll just use a different color this time. And this time I'm going to use red. And I say, okay, take this number 4. And 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. Okay, the square root of 4 is 2. Does 3 minus 2 equal 1? Yes, it does. So, what do I know about this answer? Also correct. So that's how you solve radicals, and it's a very good idea to check your answers every time, because every now and then you end up with an equation like this that has 2 solutions, and only one of those solutions will work, but in these particular examples, all of them do work. So if you have any questions about how to solve an equation with one or multiple radicals, please let me know.